Alright, our chapter 2. Data models and the relational model. Okay, last week you have been introduced with the data, information, and data storage. For what data is stored, for what purpose it is required to be managed, and how do people organize their data. People here usually of an organization, company that make use of the data. Okay, and the standard organization of data has been initiated long before 1950, 1940, and it evolves. Okay, the technology of data management itself evolved since then. Okay, we start with the first generation, second generation, third generation, and until now. Okay, and we do not say that this model is weaker than this other. This model is not very good to compare to each other because the time. Okay, maybe at that time that is the best technology we have to keep the data. In this time, we have more better technology for managing the data. Okay, so everything evolve usually. Technology the same goes to the technology. It evolves from time to time. Actually, the growth of the technology is in essence of in line with our life. Okay, there is a need to make the existing models and whatsoever technology to be improved. So after knowing this kind of requirement of data and its management, now we go to the models of the data model. Model means we data is there, is written, is captured, picture, and so on. But then with this computer technology, we need to transform the data, this kind of data, to the machine. But the data, we cannot just put it in the machine, right? We need some adjustment. We need to formatize it so that the machine can accept this data and do something with the data. So the transformation of this kind of data, we say we model the data. Data modeling. Data modeling. We need to model the data. Okay? Data modeling is something to do. Apa siapnya? Tu dapat ni lah. Okay. Answer. Cepat mana lagi? Minta maaf kan yang tu. Acidity kan? Okay. Ni ada orang. Alright. So, we need to model the data so that the machine, the computer, can understand and can do something. Because we need a machine help to manage the data. So this is what we will learn during this topic. How to model the data. Okay. Model data. Data modeling. System modeling. Where you learn system modeling? Ever heard? System modeling, SAD. You model the system, you model the application, right? And you use a diagram to model the system, the process. What modeling you use? We have to approach structured object oriented. Remember that one? So from the environment, from the real world application here, then you transform the process model into some modeling. So you transform it, you use the diagram to illustrate, okay, to give illustration to the existing situation. So you use DFD and then you use UML. So the process of transformation is known as a modeling. So now same goes to the data. We need to model the data. The verb is data modeling, but the outcome is data model. One of it you use it is a DFD, data flow diagram. And then here we have ERD for data modeling, entity relationship model. Ada ni kerusi. Okay. Right. So I split this chapter 2 into two. First is data model, and second we move to the one type of data modeling, that is ERM, entity relationship diagram. Okay, so during this chapter, you will learn about the data modeling. Why do you need to model the data and why it is important? The basic data modeling building blocks, which is what is the elements, what is features required to model this data. And then we move to the business rules. Business rules, okay, a new jargon for you, maybe, but actually we use it daily. But this is the name given to that statement, business rule. Okay, I will explain later on how the major data models evolve, okay, and the data abstraction. Okay, first, designers, programmers, the person that deals directly with the data, see data in different way. Okay, see data in different way. So data modeling reduces complexity of database design. So here, data models is a relatively simple representation of complex real world data. Okay, the structure. Often it is presented graphically. Okay, graphically. So one of the example is the ERD. When I say ERD, it should be in your mind now is the object. Okay, the two objects that is connected to each other with a relation. Okay, so this is the basic representation of an ERD. So means that ERD is one type of data models. Data model. Okay, the name is entity relationship diagram. Okay, but actually this falls under the structured. Okay, structured database. Okay, structured database. And structured database is known as relational database. Remember last week, okay, we have network database, we have hierarchy database on in the first generation, and second generation we have relational database. And then we also then it evolves to the object oriented and so on. Okay, so structured is a relational database. And one way to represent this relational database is using ERD under entity relationship modeling. Okay, so this is our data model. So we go back to the definition of the model. What is a model? Model is an abstraction. Okay, abstraction of a real world object or event, and that is useful to understand the complexity, the relationship, the situation of the real world application. Why do we need this one? Because developing database do not simply you cannot just simply key in. Like last week kan, you are in the laboratory session, you just simply create database, right? So you create the table without knowing what is this for. You create the database with IT. What for? Because you do not have one model to transfer the things or the case study you want to develop the database to your DB test. Without knowing nothing, you just know how to create it, but that one is for what? Kan? You might buat je, you isi je nama, tapi lepas tu sebenarnya nak guna tak ada, it's not meaningful. Tak ada makna. Okay, so that's why we need to model the data. model the data, okay, before submit it to the software. This is a software, the machine, okay, and then this is the model, okay, and use ERD. So you are ERD as a design, okay, design that you need to follow before you move it. So same goes as a process design. Just now I said DFD. You draw DFD, then you program it, right? But I know many of you program the system first, then you do the design. It is totally wrong lah. Tak betul. Student. I know you are programmer biasanya dia macam dia dah tahu semua ada dekat dalam fikiran. Okay, but the tedious thing is whenever you need to make a modification, then everything is not documented well. Okay, so that's why you need to start from the correct phase. Design. Before design, you need to plan, you need to do analysis, design, and then to implement, to program. Okay. So it is iterative and progressive, yeah, because remember the SDLC, the iteration of SDLC. So ni pun ada kaitan dengan inilah, dia memang kena iteratif. Sebab bila dah siap, dia kena tunjuk, kena test, akan ada comment, and then do the improvement. Okay, so the same. Right. A data model is a collection of high-level concept, okay, for describing the data, and then a schema, another new jargon for you, schema. A schema is a description of a particular collection of data. Okay, in the lab last week, you create a table, namely as customer. Good start. Customer. Store is a database, and then the table will be customer. Kan? Then you have a customer name, customer ID, customer phone number, and so on. So this is actually the information about the data. Okay, and schema is represented usually like this. Okay, schema, table name, customer, and the details. ID, name, phone number. Like this. And this is a primary key. So this is one type of representation of the schema. That table schema. So a schema is a description of a particular collection of data. Okay, using particular model lah. Okay, schema. Another schema type is in this form. Customer, bracket, okay, comma. Sorry. Another representation. Okay, but usually in the relational we use this one. Okay, schema. So please write the schema for student table. So you need to write it in this form. Okay. So the relational model of data is the most widely used relational model of data. Under structured relational database. The main concept of relational is a relation that is basically a table with rows and column. Okay, and it forms a set of records. Okay, and every relation has a schema which describe the columns and also the fields. Okay. Alright, data model. Again, another definition, a set of concepts that describe the structure of data or database, the operation of manipulating the structure, and certain constraint in the database. Ini yang definasi yang lebih panjang lah. Okay, and data model structure and constraint, it constructs are used to define the database structure. Okay, and it include elements, data types, group, and the relation among such groups. Means that sometimes you can add the data type and data size also in the schema. information, it is acceptable. Okay, data models. Alright, and this is a model operation. Remember, the basic one is CRUD, create, update, delete. And then more than that, also some transaction on the data. Okay, user defined transaction. Okay, importance, yeah, because this is the model, the design, it facilitates the interaction between the designer and the application programmer. Okay, also the user, especially the user. Okay, and the end user have different views and needs. End user, okay, remember your SMAP. SMAP has its own designer, our PTM, Pusat Teknologi Maklumat. There also is a programmer of your SMAP, and you are the user. Okay, you are the user. And how about the view of the user, student user? The structure is the same, but the content is different. So it gives us this kind of, if we lecturer can access the SMAP, currently no, we have a different view of SMAP of student. Again, the role of the user have different views, different result given by the system itself. So it is that is what is meant by different view and needs for the data. Okay. So this is a category of data models. We have conceptual, high level, physical, low level, and implementation. Okay, later on you will understand what is meant by the categories of these data models. Okay, data model basic elements. So we have 3 at least. Okay, the entity. This one is the entity. Sorry, this entity. Student, entity, student, register, course. Entity. This is a relation. Okay, relation. Okay, attribute, features of the data. So the features, this is the features. ID, name, phone, and whatsoever that is defined for that particular entity. Okay, then under the relationship we have basically 3: one to many, many to one, then many to many. So these 3 types of the relationship. Okay, and it is denoted as one to many to one, and many to many. Then the last one, yes, it is important too. This constraint, that is a restriction placed on the data. Some data we put a constraint on that part. For example, the ID must be 6 character, for example, or ID must be in the 6 integer decimal. Okay, and so on. So that is a constraint given for the attribute. Okay. Alright. So by listening that one, data models and data modeling, so I can conclude that the data modeling would be the first step in designing a database. So data modeling is a verb, the perbuatan. Okay, it is a process. You design a data before you go to the DBMS. Okay, so this is actually the application. If what process model, you want to develop certain system, the process model, okay, you draw the DFD or UML, and then you develop the software. So this is the application, implementation. Implementation. So this has something to do with the program. So the same. So now you see that we model the data, we use this, okay, graphic, and then for the system you process, you design the process model, using this graphic before you implement it. Use programming, then you develop a website, a system, and apps, and so on. Using this software, you manage the data, DBMS. So this is the implementation of data modeling. Okay. What we do in our lab last week is we implement without design. Yeah, we just implement it. We do not have a design. Okay, so that's the application. So it is a first step in design the database. Refers to the process of creating a specific data model for a determined problem domain. Sebenarnya buat apa ni? Okay. If you are required to develop a database for university, maksudnya apa? You need to go to the specific university. You need to understand. You here is a designer or analyst. Okay? You need to go to that particular organization. You need to talk with their managers, their workers, all the representatives that represent the system, who work with the system. You need to study, you need to understand their relationship. How do they collect the data? How do they manage the data? What for they collect the data and everything. So with that, they can understand before they model it and then they implement it and transfer it into the system. So this is what you are going to do during your final year project. You cannot make assumption because I'm using that system and then I just want to do it. Cannot. Because okay, this process is requirement gathering is very much important. Kalau tak dapat buat yang ini betul, maka sistem yang dibangunkan akan kurang tepat. Akan jadi mess. Saya cuba buat tanpa kaji. Maka akan macam kurang. Panel akan tegur. So this you have lacking. You lack this process. You lack this way. Why it's like this? Why is it like this? Okay. So that is a requirement step. Okay, it is very much important. So same goes here. So you need it is you want, before you want to design the database, you need to understand. You need to go there, you need to collect, you need to identify what is actually their attribute, what is their entity, what is the relationship between this identified entity, and so on. The type of relationship, is that one to many? Is that many to one? One lecturer can teach many courses or not? Or many lecturer can teach many courses? So this is very much important. Okay, you cannot assume. You cannot make an assumption for this one. Okay. Alright. A data model is then a simple representation using a graphic. Right. So now I'm building a data model. So when database designer choose or determine the entities, attributes, and relationship that will be used to build a data model, then they may begin by gaining a thorough understanding. So you need to understand. When you have this understanding, then you can develop a model. So this is the modeling process. And then how you can understand the situation. How can you identify the attributes? How can you identify the entity that is related to the case that you study? Okay, so one of it coming from the business rule. Business rule is not a rule for business, bukan. So a business rule is a statement that usually the information there containing the subject, that is the entity, and its relation. Okay, example of the business rule is one student can only register for not exceeding 20 credits per semester. This is business. Okay, one student can only have one class at one time. This is a business rule. But jangan bayangkan business tu kan. Business rule is statement like this, usually containing entity and its relationship plus some constraint. Is that okay? Example: one section can only be enrolled by at least 40 students. One student enrolls one section can be enrolled by at least 40 students. Okay, not more than 40 students. Example. So daily in our life we have this kind of things. Many. Apa contoh saya? Banyak You can only have what? One student advisor at one time, not more than that. Can only have one gadget, for example, at one certain time. So that is more example of the business rule. So from a database standpoint, data collection is only valuable when it reflects with well specified business rule. Okay, business rule. Sometimes a business rule is written properly, it's documented properly. Okay, like a student regulation. Student must attend class at least 80%. Clear, right? Very much clear. Okay. Sometimes it's not written well. Sometimes it's coming from the common sense. Okay. From their knowledge. Okay. See, this is a definition of a business rule, description of policies, procedure, or principle within a specific organization. This is a standard definition of a business rule. But for me, it is a precise statement regarding something, usually containing the entity and its relationship. Okay, and from the business rule, you should be able to define or identify the entity, relationship, attributes. Some more: connectivity, cardinalities, and constraint. Another jargon for you. Example: properly written business rules are used to define these items, entities, attributes, relationship, and also the constraints. More example. A customer may generate many invoices. An invoice is generated by only one customer for one order. Okay. A training session cannot be scheduled for fewer than 10 employees or for more than 30 employees. Ini panjang lah. Yang panjang ni biasanya ada constraint dia. Okay. So note that those business rules establish entities, relationship, and constraint. So here I hope that you can understand what is business rule that is defined under the topic of database business rule. So again, business rule is usually where you can identify the the entity and also the relationship plus some constraint. Okay, so this is the business rule. So jangan pelik if in the examination please write the business rule for blah blah blah. Nanti tak apa-apa waktu tulis perniagaan lah, bukan. It is a statement. Business rule. Okay. So the source from the business rule coming from the managers, the policy makers, department managers, coming also from the documentation like procedures, like your buku peraturan akademi, dalam tu banyak relationship dalam tu banyak. I mean that database relationship business rule for business rule for build up the database. Ada banyak peraturan dalam tu. Okay, direct interviews. This is how you this one direct interviews means that the rules is not written. It coming from the common sense and the knowledge, the experience, and so on. Okay, say like the manager said, student who wake up early usually do not feel in the class. like that. So it coming from its experience and so on. Students who get all A's in their subjects, then they may get a higher CGPA. So this is common. Right. So next, discovering this. Translating business rules into data model. Okay, remember again we have a real situation. So this is our situation, like university, school, company, organization, SME, small business, small scale size. Apa lagi? NGO, any organization. Okay, so this is a real world. Okay, real world. Many business transaction. Okay, sometimes it is an organization. It is a tangible organization. Sometimes it's an virtual organization. But whenever there is an organization, usually you can model it. So from here, everything is not well documented. So before they can use the DBMS, you need to design it first using a data model. Okay, so that's why the process is said that translating. Okay, it means that you transform the information from here to be adapt that can be used by the DBMS. Okay, so whenever you have a business rule, then you need to translate it into the model. So this is the model. Okay, generally nouns translate into entities, verb translate into the relationship. Okay, relationship can be must be bidirectional, usually bidirectional. Okay, like this. Example, a customer may generate many invoice. That is the business rule, the statement, the situation. Then how do you transform it? So using that one. Ini kita tak belajar lagi next week. Okay, this is the idea. How can you develop this relation? Good. That's right. Yes, to the supervise. Student is supervised by the lecturer. Example. How can you develop this one? Actually, it coming from the business rule. Dia tak boleh, biasanya jarang tiba-tiba baca. Dia ada ayat dia, betul tak? Then saya akan cakap 80% attendance. Student must attend class more than 50, not less than 80%. Okay? Then it comes from the business rule. Then we transform it the model before we go to implement to here. So this is how the process. Example, more example. Finalized business rules must be bidirectional. Okay, one sentence. Finalized is two sentences. Bidirectional. Student is supervised by lecturer. Lecturer supervise student. So that's why from one set of relation, it must have two sentences, two business rules, because it can be read by directional. Okay, it must have two. Jaranglah satu saja. Macam hampir tak boleh lah. A professor advises many students. Okay, professor to the student, and each student is advised by one professor. From student to professor relation. Okay, so this is how we read. Even though actually this the step we have a business rule. Okay, student is supervised by one lecturer. Okay, actually coming from here. Okay, student is supervised by lecturer. So this is a business rule. Okay, but whenever we create this one, okay, we model it into the DR, then again, we can rewrite. Okay, again, we rewrite the rule that concerning with this diagram. Okay, this two. Alright. Another example, a professor must teach many classes. Each class must be taught by one professor. Okay, business rule. Look easy, but sometimes, yeah, it's challenging also to create that one. Okay, because this is very straightforward. Okay, another example, sales representative must write many invoice and each invoice has to be written by one sales representative only. Clear? Bila baca betul-betul, betul lah. Dia adalah rule, peraturan. It is a rule. It is a rule. Tak boleh lah. Macam dia bukan ayat biasa sebenarnya. Dia ayat tu mengandungi arahan. Kan? So, this is the example. How about this? Can you do it now? I have conceptual model. Okay, I say conceptual So bila design biasanya dia memang conceptual, konsep. Bukan physical. Kan? Physical yang ni nanti dah jadi physical. Okay, conceptual. Model for the college. Student enroll is taken by class. Class is used for room and so on. Try. Maybe one or two representative. Volunteer. Okay, please state business rule for any relation you want. Here we have 1, 2, 3, 4, 5 relation. So you can detect, you can identify it by the relation. So the first one, one student must enrolled in one enrollment. Enrollment. Yelah kat sini dia dah short form kan. So sebab tu perlu yang business rule ni. Sebab dia adalah full sentence. Which is more meaningful. Bila dah design, dan setelah tu kita akan guna short form and so on. Okay? Okay? So, many enrollment can be made. Can enroll student. Many enrollment can enroll student. Yang tu mungkin tak faham sangat lah. Cuba yang professor. Volunteer. Professor dengan kelas. Volunteer please. Tak nak cuba. Professor dengan kelas. Itu mudah. Tak nak. You want to try? Okay, yeah, I know. Ada simbol yang you tak faham. Yang ni, this is one. This is many. Kita belum belajar yang itu lagi, tapi the idea is that. Okay, any volunteer? Professor, class. Yes, one a professor teaches many class. Many class is taught by or is by one professor. Nampak benda senang tadi kan? Kita tengok example. Kita bila lambat ada. Memang faham kan? Kenapa? Malu. Okay. Class is used for room. Okay, so many class is used for in a one room, and one room is used for many class, and so on. Okay, so this is example of examination question. Actually, it reflects the process. Now you are this one is like backward engineering lah, because you are given the model. It should start with the business rule. So in the exam, maybe you are given the situation and then identify the business rule, write the business rule, and then draw the diagram. Diagram. So this is the situation. Okay. Any question? No. So relationship between data models and business rule. So the data model is built to follow the business rule. Kena follow. Sebab bila tak follow, maka dia akan jadi kurang tepat. Sehingga boleh menyebabkan faulty lah dekat bahagian-bahagian yang lain nanti. Okay. Especially on the relationship. Kena pastikan betul-betul. Many or one to many ke into one. Kalau tak, it can make higher wire lah when you do the database. Okay. When you do the operation on the database. So they work together to keep your business information organized and useful. Right. So what I'm talking and explain you just now is one example of data modeling, but under the relational or structured approach. So from here you can see that this data model. So remember the evolution of database. So first generation we have network, we have hierarchy, right? And then second we have relational, we have OO, and this is the mix and so on. Okay, so this is a database. So for each database they have a data model. Jadi dia sama, dia selaris. Okay, dia adalah selaris. So this is now the major data models and its evolution. You see the first generation file system, and then we have the second. Oh, sorry, I didn't put the. This is the first is a file system. Okay, second is this one, right? Okay, then we have hierarchical and network, and then the third one is relational. Fourth is object oriented, OODB. Okay, so the data model is actually the representation. So again, for the relational we have ER. For the OO, we have OO. Okay, OODB. And the other, they have their model, their own model. Okay. Alright. So this is how do they evolve. Now, currently in this, from starting from the 20s, okay, sorry, from 2000s until now, we have no SQL. This is for the unstructured data. This is what I explained. But still, we use the OO and also relational. It's still in use. Okay, actively used. Because why relational is still used? Because the data type like that meet that relational still there. Tapi data tu sekarang dah emerge, dah jadi yang unstructured data, dah sangat unstructured. So dia kena buat satu lagi teknologi untuk cover yang bukanlah menghilangkan yang lama. Tapi yang first generation file system tu saya rasa macam dah almost diminish lah, dah tak ada. Kan yang first generation. Yang hierarchical and network tu pun dah ala-ala dah. Okay. But the relational tu pun ada ambil beberapa ciri daripada yang first and second generation. Okay. And this is the future. Actually now and future makin panas okay. Betul kan? Okay. Right. So we have hybrid DBMS, okay, and SQL data services. So this is the future of data models. Right. Terminology. Okay. Terminology. In real world, we say that a group of vendors. Okay. And vendor file cabinet. The processing file is using a file. If the hierarchical model, they name it as a segment type. In the network model, they say it as a record type. In relational model, we say it as a table. ER model, they use a entity. And OO model, we use a class. So it means that one for one particular example, they have different naming for each data model or data generation. Okay, for example, a single vendor example, global supplies. Okay, in file processing, they name it as a record. In hierarchical, they name it as segment. Network model, they say the current record. In relational, they say it as a row, tuple. Entity occurrence on the ER, and object instance in a object model. So lain model, lain dia punya nama. Tapi sebenarnya dia represent benda yang sama. Kan? Macam simple relational dengan structure dengan object oriented. Structure sebut entity. Object oriented sebut object. Tapi dia adalah benda yang sama. Cuma different perspective. Different perspective. Okay, again structured, we name the object as a entity. Okay, the subject is entity. Okay, this is entity under the structured or relational. But in object oriented, this is an object. Okay, an object. Nama dia lain, but it consider the same thing. Why do they have a different naming? Because of their perspective lah, and their format, the standardized format that they develop. Okay, so this I skip this one, data abstraction. Yeah, process of hiding unwanted or irrelevant. OO ada data abstraction, right? OO ada fungsi data abstraction yang jelas. Okay, data encapsulation and so on. Okay, means that data abstraction is a process of hiding unwanted or irrelevant details from the end user. Contoh apa? What is the example? Abstraction in your map. Apa agaknya dia tak tunjuk pada anda? Ada tapi tak dilihatkan. Ada tak? Mesti ada. In your map. Dia akan beri you maklumat yang dah bersih sajalah kan. Yang ini tak tunjuk. Okay, calculation ke ada certain data tidak akan ditunjukkan dengan jelas sehingga kita request for it. Okay, sometimes like this. Okay, data abstraction. So this is the levels. Okay, we have conceptual. Again, this one is a conceptual, and what you develop, what you insert or input to the software is a physical. Okay. Example for the university database, the conceptual schema is given like that. First one, the first entity is students with its attribute. Okay, student ID, student name, student login, age, GPA together with its data type. Okay, so this is a conceptual schema. Okay, and then when you put it into the DBMS software, then they will have a physical schema because it's already implemented in the software. Okay, relation stored as unordered files, index on the first column of student, and so on. Right. Again, our practice last week, okay, given in the lab sheet is like a schema. Okay, remember the JSTOR? It gives you the description about JSTOR, and then you are required to extract what is the entity, what is the object. So that is a schema. Okay, it is a conceptual schema. Then you activate your software DBMS, phpMyAdmin, then you start to enter, right, the schema into that one. So it becomes a physical appearance of the schema. Okay, and then external schema. Ni kita belum buat. Kita belum select all kan. Kita belum tengok lagi apa yang ada dalam. So this week kita akan buat. Yang telah. Kan tak? Kelas last week. Okay, you create database. And then you create table together with entity, data type, data size. Okay? Itu je. You ada display balik tak apa ada dalam table? Tak ada belum kan? Yang itu adalah yang ketiga tu, external schema. That We name it as a view. View. Be display. Okay. Kalau ikut exercise yang last week, maksudnya kosong lagi lah. Sebab kita tak add any apa tu? Record di dalam table tu. You just make a room to receive the data. Okay, so that will be exercise for tomorrow. Okay, for this week activity. Look at this. Conceptual. Conceptual ni pula ada yang diagram, ada yang skema. Yang physical, rupa dia pun macam yang physical the schema that you extract from the physics similar like the concept in the conceptual cuma dia mungkin lebih ada penerangan yang lebih. Contohnya data size dan seterusnya lah, ada maklumat yang lebih banyak. Okay. Why I show you this one? Banyak item yang kita belum belajar. Contohnya yang ni tadi lah, macam nak evaluate kita belum baca. Tapi kita perlu, I need to give an overview of this. It means that database is constructed properly. Database needs to be constructed properly. And how to construct your database? It must start with the planning, investigation, design, modeling, then implement it, then maintain it. So the cycle is same like you develop the software, SDLC, right? We also have DBLC, database life cycle. Sama, konsep sama. But the thing that is for software, and this one is for database. So it is the same. So that's why I need to introduce to you with this cycle first. Then we go deeper into that particular modeling construction. Okay. Summary. Okay. A data model is a data model. Is an abstraction again of a real world data environment. And designer must communicate with the environment. Must. Kalau tak tepat data yang dia extract, maka yang dihasilkan juga tak tepat. Pernah tak ada error some bug in your SMAP? In your registration, in your ada kan kadang-kadang jumpa flaw kan. Ni saya tak cakap pasal bug lah, saya cakap tentang macam logik dia macam tak logik kan. So maksudnya apa? Then that software is actually updated from time to time regarding itu kesan dia kan. Satu pelajar tak boleh masuk, sedangkan syarat dia sekian banyak jumpa, tapi tak boleh. So adalah tu kurang tepat. So that's why we need an iterative process. So again, components of modeling, data modeling, entity, attribute, relationship, plus constraint. Okay. And then we use the business rules to identify these items or this element. Okay. Which coming from the real world environment. Okay. And data model has several types based on database system itself. Okay, we have hierarchical model, we have network data model, we have relational model, object-oriented model. Okay, and then for this one, OO and relational data model, they actually adopt some features from their ancestor lah. Okay. They adopt something, some good features, but they name it as a different model. Okay. Data modeling requirements are a function of different data views and abstraction. Data views is what they provide to the user based on their query. Okay. And data abstraction is to sometimes to hide. So they not give you many things at one time. Contohnya pada satu masa, if you yes, in the system, because it's already simplified for the user, you just click. If you want to see the your CGPA, maybe you click some button CGPA. Actually, you are requesting to that. So what is behind the code? Select something, okay, based on student ID, what? Something is select the student CGPA only for what particular semester, okay, for this student. So maksudnya apa tu? Satu kena dia akan display kan, they give the result to the user. So what you see is a view. And the rest of the information they hide from you, right? So that is the process of data abstraction. Okay, can you understand this? These two situations. They do not display everything to you at one time, except you want it. But usually now they just give you what you want. Okay. So this is a current new generation of database, NoSQL database. Do not use relational model, okay, but they do support very big data, okay, big size of data currently. Offer distributed data stores that provide high scalability, availability, fault tolerance, and so on. But they do sacrifice data consistency. Can? Okay, remember that from this one, we said that there is data duplication problem. Data, apa tu? Sequence? No, occurrence. Okay? They got problem here. And then they solve the problem by introducing relational. So they create the data that avoid the redundancy. They maintain the data. They have a consistent data. Okay, here. But then when we are in this age of technology, we have many data, and then the problems come again. They create another model, no SQL for the current generation, but they do sacrifice what we have. Tapi kita tak boleh nak argue juga sebab yang ini ada keperluan data dia. Data dia dalam bentuk formatted. But here the data is unstructured. So actually they meet each other. Again, we can complement but we cannot be complete. Kita tak akan jadi selengkap ni lah sebaiknya dalam satu-satu masa. Sebab again we do based on the requirement. Okay? Alright. Another practice for you for leaving the class. Okay? Right. And next week. You want now? Next week, online quiz about 10 questions, subjective and objective, like that. Through author, make sure everyone have a device to access your author. Next week, here, 11:30 minutes. Chapter 1.